I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. We'll discuss a solution of examination question based on inclined plane. We'll find the coefficient of friction and resolve the forces. The question has been selected by the student Amy. You may join my classes, gain confidence, connect learnings, and get ready for future. Share the gift of education. Let us now enjoy the lesson with Emmy. Hi, Emmy. How are you doing?
Hi, sir. Yeah, I'm all right. Thank you. How are you?
Very good, very good. So, today, what do you want to learn?
I was hoping to continue with like mechanics, but kind of a more broad like perspective and overview of it, like it would be kind of in the exam, diving into like a variety of topics. Still obviously focused on like forces, moments, inclined plane vectors, but yeah, just seeing how we can like adapt and like approach each question.
That's very good. So, you can share the video, you can share the questions, whichever you have. Let's discuss them.
All right. So, sorry. All right. So yeah, this was like a mock paper for us, like in year 12. So I guess like I am just doing revision for the mocks that I have for year 13. But I guess a good way to like recap is everything we've learned like in the year 12 mock, and then obviously everything like that would be in the year 13 as well. So just pressing on.
Sure.
Okay.
Can you please read the question?
Yeah. So a rough inclined plane is a rough plane is inclined to the horizontal at an angle alpha, which is where tan alpha is 3/4. A brick P of mass m is placed on the plane. The coefficient of friction between P and the plane is mu. Brick P is in equilibrium and on the point of sliding down the plane. Brick P is modeled as a particle using the model. So using the model, find in terms of m and g the magnitude of the normal reaction of the plane on brick P.
So that mu is tan alpha. Okay, so that's the second part. So let's say we have a brick here. Now, if you look into the forces, this is mg.
Reaction would be perpendicular to the inclined slope.
Yes, the reaction will be perpendicular. So reaction will be kind of like this. The other force is mg sine alpha.
And mg cos alpha.
Are the other forces which are acting on it.
Right.
So to find the value of sine alpha, cos alpha, basically we need what alpha is, which is given to us. So we are saying, we'll make this triangle on the side, saying tan alpha is basically 3/4. That means 3/4, right? So opposite side over adjacent. So hypotenuse will be 5, right?
Yeah.
So
and then we can look up.
So we know from here what is sine alpha. So sine alpha is 3/5. And cos alpha is 4/5.
Yeah.
Now let's read this once again. The brick P of mass m is placed on the plane. The coefficient of friction between P and the plane is mu. So if it is sliding on this side, then mu is the coefficient of friction, mu, and the force is mu r, right? So that is the force which acts in the reverse direction. Brick P is in equilibrium and on the point of sliding down the plane. Brick P is modeled as a particle. Using the model, find in terms of m and g the magnitude of normal reaction of the plane on the brick. Show that mu is 3/4, right? Okay. So from here we can have all our equations. So let's write down the equations. We know the reaction basically is equal to mg cos theta.
So mg cos alpha, is in equilibrium. So is that like
So
a key point in terms of forces equaling each other?
yes, yes. So those forces are equal. Cos alpha is 4 over 5. So we know what reaction is in terms of m and g. So find in terms of m and g the magnitude of normal reaction on the plane. So that becomes the normal reaction. And now we need to find mu. So we'll resolve the other forces, which is mg sine alpha
Equals
mu into
mu
r.
r.
So we have mg sine alpha is 3 by 5 and mu times r, which is mg 4 over 5, correct?
Yeah.
Now, in this
And
equation, you can cancel mg and mg. You can
yeah.
find the value of mu, which is 3 over 5 times 5 over 4, which is mu. And so you get the value of mu as 3 over 4. Is that clear to you?
Yeah.
So once you cancel these 5s, so we have done part A, which is R in terms of m and g, is 4 over 5 mg, and B, which is to show that mu is 3 over 4. So basically, mu is the tan alpha value. Do you see that?
Oh yeah.
Great in
Yeah.
this particular situation. So that's a good thing to understand. And that is, in equilibrium, any mass is there. In that case, mu basically is tan alpha, right?
Is that always in equilibrium?
See, because in our equation, you can see everything is general. We have not given any particular value to anything, right?
Oh yeah.
So
It's like
tan alpha,
mg,
yeah,
all variables. Mhm.
correct. So it's just about to slide, and this is like a general case. You get the idea.
I see.
So the
Yeah. Yeah.
gradient, yeah. So basically, experimentally, if you want to find the value of mu, how do you find it? So this is also very important because let us say in the lab, we do experiments, right? In the lab,
Mhm.
experiment to find mu between any two surfaces. If you have to find coefficient of friction between any two surfaces, what you do is you actually begin by keeping a mass on a plane which can be turned. Let's say this angle theta, right? So you keep on turning till the mass actually begins to slide.
Oh,
So
I
you keep
see.
on turning. So as soon as it begins to slide, then you find rise over run, right?
Right.
And that gives you mu.
Tan
Tan
alpha
theta.
theta. Yeah.
So tan theta, rise over run, the gradient itself, is actually the coefficient of friction. So if you have a wooden surface,
Oh.
for example, right, you can put the wooden surface on a plane which can be rotated, right? So if you are rotating counterclockwise and if you adjust
Mhm.
just a bit where it starts sliding, so that gives you the coefficient of friction, and then you can find coefficient of
Oh.
friction for all the surfaces. You get the idea?
Right.
So in the
I
lab,
see.
that is kind of an experiment which
Mm.
helps us to find the coefficient of friction between the two surfaces. Does it make sense?
Right. So mu is always it always equals tan alpha like theta if the variables are all like this
Yeah.
or just anything.
Yes. So between any two surfaces. Do you see that?
Oh.
So let's say we take one standard surface, and on that standard surface, you put different masses. Right? Let's say you want to
Yeah.
compare coefficient of friction between different masses. Just put different material masses, right? And then you can find what is the coefficient of friction. So that gives you an idea of how it is related experimentally to find the value
Right.
of mu, correct?
Yeah. Yeah.
Right.
Didn't know that
Good
was
question.
clear. So brick P is now removed from the plane, and a much heavier brick Q is placed on the plane.
Okay.
The coefficient of friction between Q and the plane is also 3/4. Part C. Explain
Plane material.
briefly,
Mhm.
why brick Q will remain at rest on the plane.
So because
It's
as you
heavier.
can no. It is this body is also at the rest. You get the idea.
Mm.
This body is also at the rest. It is just about to slide. You get the idea.
Yeah.
If the coefficient of friction is same, then the status will be exactly same as it is for the given body. This body is also not moving. Do you understand?
Yeah.
So on a rough inclined plane, you can say the brick P of mass is placed on this, the coefficient of friction is this, P is in equilibrium and on a point of sliding. When we say equilibrium point of sliding, it means it is at rest. It is
Oh.
not sliding. Point of sliding means it is not sliding.
Oh yeah.
So whether mass of that body doesn't make a difference.
Hmm.
As you can see, mu is independent of mass. You get the idea. It
Right.
is independent of mass because heavier the body, there will be heavier friction, mu r.
Oh, so
Yes.
still be equating to the
So it
same
will still
ratio.
be in equilibrium exactly in the same position. You get the idea?
Oh.
Yes.
Yeah, yeah. That's really clear, yeah. Because
For the
when
same
it's
angle.
heavier, the friction is not the same as the lighter object. It actually changes the friction.
Yes. So for the
Yeah.
same angle, nothing is going to change. Only if you change the angle, it will slide. Otherwise, no.
Okay.
You
Yeah.
get it? Yeah. So that material will remain there.
I didn't realize. Okay. Yeah, that's clear now.
Okay, great. Let's move on.
Brick Q is now projected with the speed of 0.5 meters per second down a line of the greatest slope of the plane. Brick Q is modeled as a particle. Using the model, describe the motion of brick Q, giving a reason for your answer.
Okay. Brick Q is now projected with the speed of this much down a line of greatest slope. So that is the line of greatest slope. Is that clear to you? The slope is same, right?
Yeah.
So instead, we have now a body. It doesn't really a mass. We are given some mass. Let me write capital M now. Is it okay? Now is now projected with so much down the line. So if it is projected down the line, greatest slope of the plane, brick Q is modeled as a particle using the model. Describe the motion of brick Q, giving reason for your answer. So because it is projected with this speed, that means, so I think the question might be asking that what could be the angle at which it could start with this velocity? Is that the
Oh.
question which we are looking into? Or if you push it with 0.5 meters per second square, then what happens? You know, external force is applied to it to give you this velocity for the same angle. You get the idea?
Yeah. Mm-hmm.
So the question could give you two different ways of answers. So I'd like you to check the answer, then we can continue from here.
All right. Um, there. So you can see the screen, right?
Yeah, I can.
Cool.
So you see, 1C is exactly what we were talking about. Can you read 1C, please?
Yeah. So the forces acting on Q will still balance as the masses cancel, or the friction will increase in the same proportion as the weight. So that's what you're saying with the ratio being the same. The force pulling the brick down increases by the same amount as the friction. Yeah.
Now, D. The brick
So
Q
the brick
slide.
Q slides with, down the plane with a constant speed,
Mhm.
and then no resultant force down the plane, so no acceleration.
Mass can be done if they do the calculations. So what are they trying to say?
I don't understand the question.
Brick Q slides down the plane with constant speed. If there's an, they are saying if there's an acceleration, Okay, let's get back to the question. I'll answer it. So what was it saying? It slides down with constant speed.
Yeah. And then for the second mark, it was no resultant force down the plane. So no acceleration. No resultant force. What does that mean?
No resultant force. Q is not projected with this speed. So when they say no resultant force, that means there is no acceleration, right?
Yeah. And just because it's moving down at a constant speed, why does that mean there's no resultant force?
Brick Q is now projected with this speed down in the line of greatest slope. So the speed is constant. That means F equals to ma. Mass is constant, and there is no acceleration because the velocity. Speed is constant means rate of change of speed is zero. That means acceleration is zero.
Mm-hmm.
Now the thing is that if it says it is projected by this speed down in the line. So I think the answer is within the statement. So I will answer this question in this fashion. Brick Q is now projected with speed of 0.5 meters per second down a line of greatest slope of the plane. Brick Q is modeled as a particle. Using the model, describe the motion of brick Q, giving a reason for your answer. Now, in the question, we are saying that brick Q is projected with a speed. So speed is constant, right? So with this speed. So it is saying a constant speed. Of 0.5 meters per second. Is it clear to you?
Yeah.
So since it is moving with a constant speed, it means rate of change of speed is zero, right?
That's the part I don't get. Is it because of the constant part?
Yeah, because speed is same.
Oh, okay.
The rate of change of speed is zero. Or you can say acceleration is zero. So if acceleration is zero, there is no additional force applied to it.
So no additional. So just
Yeah.
additional mean
There is no
result.
change in force because
Oh,
force is equals to ma, right?
yeah.
Acceleration is zero, net force is zero.
Oh, yeah. That makes sense.
So net force is zero. Net force in this case relates to reaction R, right? So you can also say reaction R is zero.
Oh wait, when they mean constant. Oh yeah. Sorry.
So
Gradient is zero. Yeah. When you phrased it like that, it's really clear.
yeah,
They did theirs the other way, like I don't know, in terms of when I read the question first, when they said motion, I thought it just meant like you would have to use the forces or something and say that it moves downward or something.
yeah.
But yeah, so like you said, it's the answer is in the question, but the
Yes.
statement
When
they've
it
given.
says projected now with this speed, so down the line of greater slope, right? So
Right.
so basically it will move down either, if this mg sine alpha is more than mu r cos r, right?
Mhm.
It's going to move down. But since they say projected with the speed of this, we'll assume that this is a constant speed all throughout. And
Yeah.
speed is constant all throughout. Rate of change of speed, which is rate of change of velocity, because we know the direction in which it is going. So if
Right.
you know the direction speed is same as velocity in this case, we can say that the direction is along the line, right?
Yeah.
Along the line of greatest slope. So that gives you the velocity. Is it okay?
Yeah. Yeah.
So since the rate of change of velocity is constant, that means, zero, right? Because velocity is constant. So
Yeah.
acceleration is zero. Acceleration is zero means force is zero. If force is zero, that means the reaction force is also zero. So all these
Yeah.
forces are zero acting on it when it is sliding at a constant speed. That's
And
what
no
we
change of force. So there's no like resultant force, like nothing to subtract from anything. Because there's
correct.
no change in force.
Right.
Yeah.
So that is how we could explain it.
That's very clear. Okay.
Okay.
So I can use the question itself to help out if I get stuck.
Yes, you can.
Probably there's the answers in the question.
We'll take the question on vectors in the next lesson.